A system composed of three spherical objects with masses 3 kg, 2 kg and 4 kg, and their centers located at -6 meter 0, 1 meter 0 and 3 meter 0. If you look at the coordinates of these three locations, the y coordinate of each is 0. It means they are points along the x-axis. Alright, let's place these objects. Let's place the first object. Where is the 3 kg object? The 3 kg object is at -6 meter 0 over here. M1 equal to 3 kg, x1 equal to -6 meter. So this is our M1, that is the 3 kg. Where is the 2 kg? M2 equal to 2 kg, x2 is at x equal to 1 meter over here. This is the 2 kg. And where is the third mass? The 4 kg. M3 equal to 4 kg, x3 equal to 3 meter. It's here. That is our 4 kg. We got three different objects on the x-axis. How do we figure out the center of mass? Well, the center of mass of these three objects will be somewhere on the x-axis given by x center of mass, and there are three objects. So it will be M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3. Let's use all the values. M1 x1 3 times -6 plus M2 x2 2 times 1 plus M3 x3 4 times 3 divided by M1 plus M2 plus M3, and that gives you -4/9. The position of the center of mass of these three objects is at -4/9. It's somewhere here. Of course, the y center of mass is 0 because all these objects are placed on the x-axis. So the center of mass is at this point, -4/9, 0. And where is that point? It is right here. This is the x center of mass, which is -4/9, 0. Okay, let's do another one. Find the center of mass of a system composed of three spherical objects with masses 3 kg, 2 kg and 4 kg, the same three objects we used last time, but their centers are now located at 0, 5 meter, 0, 0 and 0, -4 meter. You can see all the x values are 0. That means these points are along the y-axis. Let's locate them. M1 is 3 kg, Y1 is 5 meter. That means your M1, the 3 kg is over here. M2 is 2 kg, Y2 equal to 0. Our 2 kg object is at the origin. Alright. M3 equal to 4 kg, Y3 equal to -4. Where is M3? M3 will be over here. That is the 4 kg. We now need to find the position of the center of mass. The position of the center of mass of these objects will be a point somewhere on the y-axis. What is the equation? Y center of mass equal to M1 Y1 plus M2 Y2 plus M3 Y3 over M1 plus M2 plus M3. All we need to do is replace these by their values. So M1 Y1 is 3 times 5 plus M2 Y2 is 2 times 0 plus M3 Y3 is 4 times -4 over M1 plus M2 plus M4, and that is -1/9 meter. Y center of mass, the position of the center of mass of the Y center of mass is -1/9 meter. And what is the X center of mass in this case? Because all of them are along the y-axis, the X center of mass will be 0, and therefore the location of the center of mass is at 0, -1/9. Where is that? It is actually very close to the origin where I'm pointing. There, that is Y center of mass is 0, -1/9. Okay. We have now 3 balls A, B and C of masses 3 kilogram, 2 kilogram and 1 kilogram are placed as shown in the figure. So this is your A, this is the 3 kilogram, this is the B, which is your 2 kilogram, and C is our 1 kilogram. I hope you can see that C03. I think it is cut off. Okay. C equal to 1 kilogram is at 0.3. Is that right? Is this right as 0.3? Well, that's not right. This should be 30. Is that right? I must label this point as x equal to 3, y equal to 0. So please make that correction. It is not 0.3 but 30. Okay. We will now need to find the center of mass of these 3 objects. Now you notice that each object has an x position and a y position. Object A has an x position equal to 2, y position also equal to 2. Object B has an x position equal to 1, y position also equal to 1. Object C has an x position equal to 3 and the y position equal to 0. I hope you made that correction. This is 30. That means there will be an x center of mass. The x center of mass will have an x. The center of mass of these 3 objects will have an x value and a y value. And we can find them separately by using the x center of mass formula and the y center of mass formula. Alright, let's do that. M1 equal to 3 kilogram, x1 equal to 2 meter, you see that? x1 equal to 2 meter and y1 also equal to 2 meter. x1 equal to 2 meter, y1 equal to 2 meter. M2 equal to 2 kilogram at B, x1 equal to 1 meter, x2 equal to 1 meter, y2 also equal to 1 meter. How about M3? M3 is 1 kilogram and x3 equal to 3 meter and y3 equal to 0. Now once you have x1, x2, x3 and m1, m2, m3, we can find the position of the x center of mass. And then you have y1, y2, y3 and m1, m2, m3, we can find the position of the y center of mass. Let's do that. X center of mass is m1, x1 plus m2, x2 plus m3, x3 over m1 plus m2 plus m3, and that is 3 times 2 m1 x1, 3 times 2 plus m2 x2, 2 times 1 plus m3 x3, 1 times 3 divided by 3 plus 2 plus 1, and that's equal to 11 over 6 meter. The X center of mass is 11 over 6 meter. Okay, how about the Y center of mass? Y center of mass is m1 y1 plus m2 y2 plus m3 y3 over m1 plus m2 plus m3. And now use these values. m1 y1. m1 y1 is 3 times 2 plus m2 y2 is 2 times 1 plus m3 y3 is 1 kilogram times 0 meter divided by m1 plus m2 plus m3, and that is 4 over 3 meter. Therefore, what is the location of the center of mass? The center of mass is located, which has an X position 11 over 6, Y position 4 over 3. Now where is 11 over 6? 11 over 6 is very close to 2. So the X position 11 over 6, Y position 4 over 3. So this is the position of the center of mass. It will be 11 over 6, 4 over 3. Okay, let's move on. We will now talk about